Hello, look at us on our second video, and actually the last video this week. I only did 2 for you all this week, so you're welcome. Um, we are going to talk today about the volume of cylinders. I am very distracted. My dog has decided that this is where she needs to stand. Literally, like right here. Like, is this really the appropriate place to be for a big, giant American bulldog? No, it's not. And you're pulling on cords. Teaching from home. This is fun. Okay, so let's jump into this then. So we are on volume of cylinders. The nice thing about volume of cylinders is really, if you get what we just did, this is going to be pretty easy. It's the same thing. There is one thing that I do kind of want to add on here, so we'll look that up at the end. I meant to write it in the notes, and I didn't, and then I decided not to, but we'll talk about it in a sec. Okay, so the volume of a cylinder is found basically using the exact same ideas, same principles as what we did for a prism. The only difference being that instead of finding the area of a base using one of our area formulas, you're just going to use the area of a circle every single time, because it's always a circle as the base, right? That doesn't change. It's always a circle in the base. And with that, we use the same formula. That means volume equals big B times h. What's important to remember is that if there is a circle in the base, you replace big B with pi r squared. Whereas if there is a square, you replace big B with base times height. If there's a triangle, you put 1/2 base times height. You just got to be mindful of what shape you have so that you replace big B with the correct formula. So I think that actually puts us right into the first examples. And let me put this here. So it says, determine the volume of a cylinder as the exact value. So jumping over here to this first example, we want to find the volume of the cylinder as the exact value. So the first thing that we always have to look at is the area of that base. All about that base. No treble. Boop. All right, so I've got this circle that's 5 feet. So I know that if I'm going to find the area of that circle, we're going to use pi r squared. Now, it did say to use the exact, right? It said example 1, find the exact area. So we're just going to leave pi as pi then. We're not going to actually change it into a number or anything. So I plug in my radius, which is 5. So I have pi 5 squared. 5 squared gives me 25, so I have 25 pi. Done. There is big B. So then I come over here, and for my volume, I do volume equals big B times h. So I end up with volume equals big B we just said was 25 pi. And the height, or the distance between the two circles, is right here, 11 feet. So I'd multiply that together, and 25 times 11 is 275. And again, we're going to use our units cubed because it's volume. Done. Just like that. All right, so there is my prettier version. All worked out in pen with my favorite colors. All right, go ahead and pause that if you need it. Copy it down. My second example says, given that a cylinder has a height of 7 inches and a volume of 252 inches cubed, find the radius using 3.14 for pi. That is important. If you use the pi button here, you may end up with the wrong answer, and that's significant in IXL assignments. IXL doesn't let you just slide with getting the wrong numbers. You've got to make sure you plug in the correct value. If they tell you use 3.14 for pi, use 3.14. If they tell you use the pi button, use the pi button. If they say use exact, then you don't use anything for pi. You leave it as pi. So just, again, be careful with that as you're going through that. Make sure that you're paying attention to what that's asking you. Okay, so we want to find this cylinder. So I think the first thing that we ultimately have to do is we got to draw a cylinder, right? So I'm going to draw a circle, go straight down, draw my circle shape on the bottom. Done. Okay, so ultimately they told me it has a height of 7 inches. So I know that this is 7 inches. And I know that what I'm looking for here is the radius, right? I want to know what the radius is. That's important to find. And I know the overall volume is equal to 252. So what that tells me is if I take this formula, volume equals big B times h, I know a lot of those key pieces there that I need. I know that the volume is equal to 252. I don't know what big B is, but I know that big B is the area of a circle, and the circle is pi r squared. I don't know what r is, though, so I can't actually do anything there. But I could write it like that, pi r squared. And I know my height is 7. So with those things, I can plug that all in then and see what I can work out. So I've got volume is 252. My big B is pi r squared, and my height is 7, so I'll put my times 7 there. So I have this little equation now that I can just work through, right? That's super simple to do at that point. So I'll start by getting rid of the 7 on both sides. So divide by 7, divide by 7. That cancels. And if we divide 252 by 7, we get 36. And over here I have pi r squared. Next thing I got to do is I got to get rid of the pi. Now, we're going to be very mindful of the fact that it said use 3.14 for pi. Don't use your pi button because you'll get it wrong. So divide by 3.14, divide by 3.14. My pi and 3.14 cancel, and this leaves me with a decimal, right? It's a crazy decimal. You'll want this decimal in your calculator. You want to leave it in your calculator. It rounds to 11.46. Thank you, Alice. I don't know if the whole computer shook or not. So I have 11.46 equals r squared. Again, like I said, leave that in your calculator, though. Oh, look, my camera went up. She did. She unplugged it. I hope you can all still hear me. Let's see. Allison. You beast. You monster. I told you, she won't leave me alone. She won't do it. Let's see. Camera, restart. Technical issues. Hold, please. Activate. There, I'm back. Okay, that was fun. That's great. Good job, dog. Good job, dog. Okay, my whole screen's moved over too. Okay, so coming back into this, again, like I was emphasizing, keep that in your calculator because this is like a long repeating decimal, right? But ultimately now we know that we're going to have to square root both sides. So I know that I'm going to come in here, I'm going to take the square root of this 11.46, take the square root of r squared. That's going to cause the r squared to cancel into just r. And if you keep that in your calculator, you would get I think it's 3.8 something, but it rounded up to 3.39. Again, don't take anything out of your calculator till the end because you don't want to end up with the wrong number. If you did, you may have gotten something slightly off than me. So be sure to keep that in. But 3.39 would be your radius. Let me put up again my nice version. And that would be it. So again, if you do need some more help, please pause the video and copy that down. Sorry, if you need to copy that, please pause the video and copy it down. If you need help, please come see me at office hours. There's one other thing that I forgot to put in my notes that I do want to show you. It's called the Cavalieri principle. I think I always say it wrong. Cavalieri's principle. No, I'm saying it right. So I'm just going to kind of throw up a quick just Google lookup, right? A Google thing. Cavalieri's principle just says this, and you can see it here with this stack of quarters. That's usually how they represent it, but I'm going to put this picture up too. It just says that the volume of a cylinder is the same regardless of if that cylinder is standing straight up or if that cylinder is crooked or if that cylinder is going all over the place. So the volume of this stack of quarters on the left, or whatever coins those are, you can see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 coins there. Those 12 coins have the exact same value as these 12 coins on the right, even though those 12 coins on the right are all kind of jigged and out of place, right? They still have the same volume. So if you saw a problem like this, find the volume of a cylinder that has a height of 16 and a diameter of 10, well, you'd still solve it the same way as what you just did. Just because it's slanted doesn't change anything. And Cavalieri's principle actually applies to all cylinders, or sorry, all prisms. So any prism shape like this, it's going to apply to. A straight up prism, like these two here, is going to be the same as the slanted prisms for their volumes. So just kind of keep that in mind if you see any questions like that. Other than that, I think that is it. So let me know if you have any questions this week. I'll talk to y'all later. Bye!